I had a couple of things to show you today before we start on the official chapters. Now we're up to the right time. And I just want to talk about white hatting. I was reminded of this. I've got a project I'll show you later when we're not broadcasting on TV, because I've got to wait for the informed consent nonsense to go past, or non-informed consent, responsible disclosure. But I saw him today. Meng Chao did this. Meng Chao runs the workshops at the Wall of Sheep at DEF CON. I've known him for years. I also work at the Wall of Sheep at DEF CON. And his students have been doing a lot of really good stuff. And this student here checked this dating app called Coffee Meets Bagel. Now, I didn't know there was such a thing, but apparently this is one of the dating apps, and he did a wonderful job figuring out this thing. What he did was, you install this app on your phone, then he ran it through a proxy. He used the Charles proxy, which is pretty much the same thing as Burp that we use here, and he watched the traffic. And he found out what it does. You can decide to find people near you in the dating app, and you can put in the location to be anything you want. So you can find anybody anywhere, and it will load the people near you. And when it loads them, you're only allowed to find out a little bit about them before they friend you. But the way it works is it downloads everything about them onto your phone and then only shows you some of it. So all you have to do is look in the proxy and you find their exact location, latitude and longitude, with enough places to locate them to within a couple of feet. So you find out where they live. You find out all the information in their profile, which they haven't cleared. So he can read everybody's data about everything, everywhere, by just looking at the network transmission. This is, one of those many security designs where they just didn't think this through. Let's download all the data on the phone, then only put someone on the screen. That's privacy, right? Anyway, so he proved this, and he tried to tell the phone, the company, and they wouldn't even talk to him. So now he went public, and that may shame them into it. So this reminds me, I highly encourage you people to do the same thing. When I taught the web app vulnerability class, Android apps are so terrible, you can just use any simple technique and find holes like crazy, like just Wireshark or anything. Tons of them are sending personal data unencrypted over the web and data that shouldn't be there. I know a couple of years ago, Kirk was looking at the zone alarm firewall and it's sending all kinds of private data all over the place, and all you need is Wireshark to see it. And you can totally do it now with websites.
Windows.
What's that?
The easiest way is Windows, and the data, the bytes received and sent on the network.
Well, sure, but you don't see what's happening then.
No, I'm saying that's the first place I saw it. Is that I had bytes coming and going.
Yeah.
But I wasn't sending anything. So it was before zone alarm.
Okay. Anyway, so I'll just mention some. I've been doing some of this. This stuff is called white hatting, and so I've been going through the top 10 retailers. I got the ones in America. And if you just look at these, you find interesting stuff. And it does take us a little deeper into Burp than we've been. And I'm adding some versions of projects here. But let's take a look. We already looked at Amazon last time. We narrowed down which cookie was authenticating us at Amazon. And if you look at Walmart, Walmart actually does it pretty well. Let's bring up Walmart here. Here's Walmart. If you go into Burp, and let me make it bigger. I can get, there we are. And all right, let's go to Walmart and log in. I appear to be logged in. Yeah, not me, sign out. Okay, good, now I'm ready to log in. So let me catch the login, because now you could test many things, but the first thing I always test is the login to see how it works and whether you can do a brute force attack and things like that. So let's clear this, and let's see how the login works. So here I am signing into my Walmart account, and now I'm in. I've got a name of test up here. So the very first request here looks like the request that made the login happen, and I think it's got my name and password here. Yeah, see what happens, I don't quite know why this happens in Burp. The name and password in this request do not appear as normal parameters. They appear in the data of a post request down here, but there's my name, and there's my password. So this is the login request that sent up the name and password to their server, which is fine. Now the response is 200 OK, which is reasonable. And the response sets a whole pile of cookies. Some of these, no doubt, record who I am. And then at the bottom, it has a status. And the status says, OK, first name is test, and so on. So that's a successful login. So the first question is, can I just repeat that? Do they have any kind of, I can send this to repeater. Is this one packet enough to log in? Or is it smart enough to notice that I didn't really come from a browser and that I'm sending exactly the same data over and over? So let's send this to the server, and I get 412 precondition failed. So this, I thought, is a sign of good security. This is what you find in the textbook. We've been talking about it in the last several chapters. You should have something like a hidden form field to make sure that if someone logs in, they actually loaded a page from your server into a browser and replied from that page. And then when the next person logs in, they should get a page with a different page field, so it can tell that I'm just replaying a request for something that's already logged in. So it won't let me just repeat the old one. I would have to really load a page in the browser and be another user. And apparently they're doing something like that with a 412 precondition failed. So this is a good sign of Walmart doing the right thing. All right, and Costco is more interesting. So let's try, let's get to Costco.
What's wrong with that?
Costco, I could get a little further. All right, here's Costco. And let me see if I'm locked out or if I make a new account. If I sign in, let's try test 1001 and see if I can get in. Okay, let's clear this old junk out of here. And go to the proxy and clear this stuff out of here. Okay, let's capture a login request at Costco, which is here. Good, I got in. Okay, because I do get locked out rather frequently, as you're going to see. So here's something called post logon. That would look like the right one. Let's see if it has a parameter. This one even has a parameter with my password in it and a parameter with my email in it, so that's pretty good. This is pretty obviously the login request. So you might wonder if I can repeat it. Let's send it to repeater. This response comes out with 302 moved temporarily, which I found is pretty common. It's moved, but it takes this opportunity to set a bunch of cookies and then move you to some page like the logged in home page. So that's 302 doesn't mean you failed. So if I go to the repeater and I send this again, I get the 302 moved temporarily. So this is not as smart as the previous website. It doesn't care that I'm repeating the request in something that's not a browser. They didn't put a per page token on there to make sure that I'm really coming through the official app. So you might wonder, how dumb are they? So let's try a brute force attack on the password. If you send this to the intruder, I haven't got this in the projects, I think, and it's really quite good to know. Here's how the intruder works. Here's the target on 443 using HTTPS. This is how it works. It guesses what parameters you might want to mess with and labels a bunch of them, and it's nuts, so I'm going to turn that off. Clear everything. Okay, what you do, I'm going to do a sniper attack, which is the simplest attack, which just means leave all this the same and take one field and try various values in that field. Simple brute force attack. So all I want to do is find the password, which is down here. Logon password equals password. And what I'm going to do is take the last letter in the password and vary it, just to see if I can get away with that. Because if I can do that, then I would write a Python script and see if I can really try 1,000 passwords. And if I can try thousands and thousands of passwords, then I've actually found a vulnerability. Because then you could reasonably go through the most common passwords. So let's see if it'll fall for that. I go down here and highlight the last word in password, and then I hit this add section mark thing. So that's now the target for a sniper attack. Now you go to payloads and you load options. So I'm just going to put in the alphabet: A, B, C, D, E, F, G, H, I, J, K, L. That's enough. So I have a bunch of letters in there, maybe 10 letters, and the D is what will succeed. That's when my password ends in D, which it does, and all the rest are going to fail, and I want to see if it will let me do that, or if it has some kind of defense stops it. So I start the attack, and off we go. There it is. So it sends the request. Here we go, A, B, C, D. Now you notice that I'm starting to get 403 responses, and they're all 761 bytes long. So I got 302, which is, remember, that was what we expected. 302 redirects only 4 times, and then I started getting 403s. And it's saving all of these, which is cool. So if I look at, say, the A, I've got the full request and response down here to look at. So I sent a request, here's the response, 302 moved temporarily, and I think down at the bottom there'll be something like a status, but I'm not seeing it. So there's a 302 moved temporarily here, and I don't actually know how to tell that I failed to log in. But anyway, here's one. The first thing this attack does is it sends the unaltered data. So the first one should have let me in. So this is a successful login, and you can see it sets a whole bunch of more cookies. So it's bigger. So 2904 is the length of a successful login, and this is the length of a rejection. So if I saw nothing but those 2 lengths, I'd have the chance for an attack here. But take a look what happened. B rejected me, and so did C, but D gave me a 403 forbidden. And now it says you don't have permission to access this page. And if you render it, you'll see this is what you're getting. So just 4 or 5 repeated guesses and they locked me out. This is what you should do. Costco is doing what your textbook says to do, what we should all be doing. They're monitoring the traffic. If you get some malformed traffic, it's obviously a hacker. You just block them. Now, I don't think they blocked me. I hit this several times today practicing. It doesn't block me forever, but this is what you should do. They're paying attention and locking you out. So they're a good example, which is why they're here at this part in the lecture. The bad examples have to wait till later. So that's the game, and I thought that's good to see. You get banned after just a few guesses. That's what you should all be doing. Kroger. I did the same thing with Kroger, and when I tried Kroger at Phil's Coffee, then I got about 10 guesses before it locked me out. And down here again, status code, user ID locked. It didn't give me a 404 page, so I was not allowed to see the page. It locked out my user ID, which is also a pretty good thing to do. There's something wrong with this user, somebody's attacking them, locked them out for a while. So that's fine, but then I went down the street to PokeHub. And I ran the attack and it went all the way through without stopping. So the thing about Kroger doesn't exist on the West Coast. They're an East Coast company. So I had to lie and tell them I was in Pennsylvania to make my account. Oh. And when I go to Phil's, I'm in California, like I am when I come here. But when I go to PokeHub, it authenticates me as being in West Virginia. Because apparently PokeHub's corporate network, their actual point of presence is in West Virginia. So if you surf the web from PokeHub, you are geolocated as in West Virginia. And from being in West Virginia, there was no limit, because apparently I'm more believable. But I couldn't create a new account. When you create a new account, you have to put in your number, and they say you can use any random numbers, so I only had to try 3 or 4 random numbers coming from California to get in, but no amount of tries could ever get me in here. I even tried running a sniper, guessing random numbers. And so I'm hitting different servers with different rules when I come from West Virginia than I am when I come from California. So anyway, that's kind of like what we saw when we were looking at Amazon, how you get different cookies indicating I am hitting different servers at Amazon when I'm supposedly going to the same URL, and they don't all act the same. So anyway, I'm not quite sure whether they're called Kroger smart or stupid, but I guess I'll call them more interesting. You know, they do have a lockout, but it doesn't work based on geolocation, and that might be reasonable. I don't know. It's interesting. Then there's Home Depot, which has something really cool. If you go to Home Depot, in fact, let's do Home Depot, because Home Depot shows a defense I've never seen before, which is interesting. Let's go to Home Depot. Okay, here's glorious Home Depot. And I'll wait till I'm ready to log in. Let's clear this attack page. Is that an attack page? I guess not. Yeah, it is. So how do I clear it? Throw this way? No, I don't want to do that. All right, I wanted to go back to proxy. All right. So here I'm at Home Depot, and I think I'm logged in. Good, I'm not logged in. All right, so I can sign in. And by the way, I can't hit the sign in button. It actually makes sure I clicked in these before I sign in, which seems a little excessive to me, but anyway, that's neither here nor there from a security point of view. So let's clear this junk out. And then log in here. And we'll see if it lets me in, and it seems like it did let me in. Okay, good, so I'm no longer locked out or anything. So here's a thing called post, and here's a thing called post. Okay, take a look at what happens here. Here's a thing called post customer account sign-in. That would appear to be the login. And if you click on it and look at the parameters, I don't see the username and password, but if I look at it raw, there they are at the bottom, username and password. So this would appear to be the login. And the response is 200 OK, and down here, customer account ID, login ID, this accepts me and then gives me an identity. So it recognizes me, which is fine. But if I try to repeat that, go to repeater, and send it from here, now I get 401 unauthorized. And this, if you, user is not authorized, developer error message. And so what's going on here, which is pretty cool, my opinion is, it doesn't accept post. What's going on, it made this weird options request. I've never seen anything deliberately use the options request before. It made an options request to the same URL right before the post. So it does an options request, which opens a post for like half a second, lets the post in, and then it slams it shut again. This is like port knocking. And I tried to program this and I haven't found any program that works. It does 2 sets of options post. First it does an options post to decide if your user ID is okay, and then it does another one to let you log in. Well, this one did it just once. Anyway, if you wanted to automate this, I just ought to mention, you could take the options in the post or either, you right click and copy as curl. Now you can write bash scripts that will do it.
Back to back.
Just post, it will make a bash command. This is all a single curl command that will do it. And that will send it to the server and give you the response, and here's that user is not authorized message. And you can put that in a bash script, and you can take it to a web page, which I think I showed you last time, maybe I mixed it up with another class. If you go to the page for this class, I put it right at the bottom, although I think it's got another link down there. Here's the page. This will convert that curl command to Python, the request module, so you can just totally, however, I have found several pages where the curl works and the Python does not work. And at the end of this, he has a comment saying, this is pretty hard, I'm not sure it's always accurate, and I guess it's not. So one thing I found when that happens that works is to go back like we did with Amazon last week and trim the request to make it smaller and simpler, and then put it in Python and it works. Anyway, you can automate things this way, but I can't find any automation that will get me into that retailer. Whatever they're doing is like port knocking, and it certainly stops simple tools. So it's kind of cool. This isn't probably security through obscurity, but they're actually using the options method. If you don't do the option method, you don't get in. So anyway, that's what I thought I'd show you, and I highly recommend you to do these things. If you do investigate retailers, be aware, there's some legal risk here. Now, in America, Staples got mad at me. I went through the Staples app, I found it was insecure, they ignored me, so I made them homework, I made videos, I demonstrated it at conferences, and they finally sent me a lawyer threatening me, saying you're violating terms of service. And I checked with my lawyer and he said, your opinion has been noted and it doesn't matter, you have the right to investigate the security of an app you're using, even if they tell you not to, but you might get legal threats. So anyway, I highly encourage you to do this kind of research. Be careful, don't do anything extreme, and talk to me. Work with me, I have a lawyer, so some of this is legal. Now, if you actually get in other people's accounts to take their money, then God have mercy on you. But if you make your own fake account and figure out some way to forge the cookie to get in your own fake account, almost anybody would regard that as reasonable. And as long as you present it the right way, you're okay. So if you want to do this kind of research, talk to me. We'll work together. I've had two students went to DEF CON to give talks last DEF CON. One was approved and one wasn't, but they both had great research, and one of them hacked into BART. And that student was very concerned about the legal consequences because the people who hacked into the Boston subway, people got a world of hurt. It turned out to be okay. But anyway, that's very good stuff. And there's a right way to do it. And the right way to do it is, work it out, talk to me. I have a lawyer, and talk to the EFF, make sure you have some cover before you go public. But it's of course worth extra credit, and this is how it's really done. And it's very close to political activism. You have the right to investigate the security of public companies that are taking people's money, just like you have the right to criticize your church leaders and your political leaders, but you can't expect them to say thank you. And they will, of course, try to scare you away with lawsuits and stuff. And certainly, there's a limit where it's actually illegal and you'll actually get punished. So don't talk to me before you go too far, but I highly encourage you to do this kind of work, and I think Ming's student did the right thing with some dating app, finding out that they're spraying this data everywhere. That's perfectly fine. It is not required to tell the company at all, but it is considered polite to tell the company and wait 30 days before you go public. So that's what I always do. If anybody ever listens, I might even give them more time, but that almost never happens. Nobody could care less about anything I tell them about. But if I actually found a way to forge the cookie and get right into anybody's account, I think they would actually fix things like that. Everything I find is more minor than that, and companies don't really care about anything more minor than that in my experience.
How about Office Depot and Best Buy?
I have not tested them.
Huh?
I have not tested them. I tried to test Comcast, but you can't make an account. So I can't really do much of anything.
No, you have an account.
Yeah, but I'm not going to get my own account locked out and lose my internet service.
Oh, yeah.
I need to be able to make some test accounts. Or it's really not. This is why I couldn't test very many banking apps on the phone either, because you can't just make an account. You have to actually...
On Comcast, you can make a child login. If you log into your main account, you can make a...
Yeah, but if I get that locked out, I think I'm still afraid I'll lose my internet service.
Yeah.
Anyway, all right, so anyway, on to the book. We'll talk about access controls now. We got a couple of short bits of chapter here. So, all right, So authentication and session management, once you know who people are, you've got authentication cookies or something, then we've got access controls. Now that we know who you are, we want to have some limitation on what people can do. And you have to enforce these for every request and every operation. So here's the common types of vulnerability. Vertical privilege escalation means increasing your access level up to administrator. Horizontal means going over to another user at the same level. And context dependent is something else where you get to access pages out of order or otherwise violate the business logic. So reading another user's email, if you are a user with email, is a horizontal escalation. And if you can do things that should not be possible in context, like I was just doing, I was able to go to one of those logins and send extra login requests without really coming from their form. And when I tried to just do a whole bunch of them outside, that's the kind of thing you shouldn't be able to do. And like you saw, several of the retailers are smart enough to enforce business logic with page cookies so you cannot access a page in any way other than the expected way, which is what should happen. So then there's completely unprotected functionality. This is where people just can't be bothered to keep track of a session cookie or anything, so they just put up some important page like an administrative page and they just give it a complicated URL, put it in this folder with a special name, and then they hope you won't find it. So that when you log in, they give you a link to that page, and they say, well, the other people didn't log in and they'll never find that page. This is like hiding a key under the mat. There's no actual access control. It's just hidden to where they hope you won't find it. And this is, people call this security through obscurity, and there are two problems with it. The first one is you are assuming that people cannot search for it and find it, which is just an assumption that nobody else is smart, just like homemade crypto is. You scramble the bits and you say nobody will figure this out, and it just shows your ignorance of the brilliance of mathematicians who have figured out ways to find things that don't look obvious. And the second one is, once it is broken, it's totally broken. It's brittle security. There's no defense in depth. So anyway, you'll have something like this, do admin menu 2, and you hope they won't find that name, but of course, it's not that unlikely that somebody will find that name. You should remember that even if that is 50 random characters and nobody will ever find it by brute force, your staff will just email it and print it on paper and throw it in the trash and accept bribes. You know, humans know it, so it will leak out.
Once you post it on the dark net, it's...
Yeah. So, you know, it would be a whole lot better to just actually have some kind of authentication cookie that you actually have to have right to get in there. So, all right, you may not have a link to the URL, but you will often find that in the source code, there are links. So in here, there's a menu inside the source code, which goes to the hidden thing. And you can often, you might pass it in as a parameter, like you have a document ID, it's just a long number here. You see this on pages that host a lot of things, like people that sell books or something. And one thing people do is they have a server, which like just FTP, serving up all the books. Then they have a shopping page that gives you the link, and now you can download it from the server. And once you have the link, you can download as much as you want. I know you found that most of the Microsoft operating systems we use are that way. And once you have the link, everybody can just get on as many copies as they want. It's just the purchase process just protects it. This is, of course, comes when they have two separate systems at the company, and there is no real way to pass authentication information from this one to that one. It's complicated, and this is why Microsoft sells federated identity management servers. That's what federated identity management servers do, is somehow take your Active Directory login from here and translate it over to this other company so they can still know who you are. And it is complicated and expensive, but it's got to be done if you don't want to just have wide open doors.
Actually, but the software is just a download. Some OSs is download manager and then download script.
Yeah.
So you need two. That's all the two things you need.
Yeah, that's right. And that's more security through obscurity. Anyway, so your document identifiers might be predictable, and the URLs are not treated as secrets anyway. So anything in the URL is going to be in bookmarks and server logs and proxy logs and just sort of sprayed all over the place. Another one is, of course, multistage functions. So if you're making a new user, you take the user function, then you select a department, then you select a role, then you put in username and password. And if they don't have these per page tokens that change every time to make sure that you got here from here and you got here from there, then I can just skip over some of this and go to the end. And now, when I put in the username and password, it doesn't remember whether I was the administrator or not. I can tell it, oh no, I was the administrator. Because it didn't really enforce my passage through the pages. And like I say, here's the really static files. You just have a bunch of files on a server and you sell the links to them, but there's no actual access control because the file hosting provider doesn't really have access to the database of users and permissions, so there's no way it can really limit who gets in. And this is, of course, not very wise. Anybody with a link can then just post that link on BitTorrent and everybody can download a copy of the book. All right, then you might decide rather than restricting the individual files, you're going to restrict a folder, the name of a folder or something. Only administrators can access this path. Now that might be okay, but the problem is if you do this in, say, Apache, in the configuration file, it is very common that people only restrict the get method and not all the methods. Because Apache configuration files are confusing. It's hard to find, they're sprayed all over the place. So you might find that you can just change the request method to something other than get and get through. And that's called verb tampering, and that's quite powerful. And we were just seeing that one of those retailers, Home Depot, actually uses the options method. First time I've ever seen it actually used by somebody. So you can use unusual methods and you'll often get through. Another fun fact is there are web servers that will let you type in any funny word for the verb, and if it doesn't recognize it, it will treat it as a get. But when it compares it to the access list, it will not treat it as a get. So if you block get, I can just type get, and it will act like a get to harvest the resource, but it will not be interpreted as a get to be blocked by the permission rules. So just putting in junk for the verb sometimes works, which is pretty cute.
Just return the commands that you will accept?
That's what it's supposed to do, but on that server it doesn't. And this is the dirty trick. Remember, the rules are not fixed. You can do anything you want on your server. You can define your own verbs. You could put weird parameters anywhere. It returned weird stuff.
Okay.
Yeah.
There's a funny thing with dumb question on your website. If someone puts in a dumb word after sam's.info,
yeah,
it does that 404 by it's automatic. How's that set in your account?
Yeah, if you. This is actually
any word after your website.
Yeah, no, I know what you mean. This is actually
automation. What automation is that?
If you go here and you put in
dummy.txt or something.
Okay, you get this. Now see, this I had to do this because there was a vulnerability at my web host. See, if you have a web host, I had one in one. If you don't define custom 404 errors, there's a generated one, and what a lot of them do is put ads in there, and this one actually had an ad with a field with a cross-site scripting in it. So it was vulnerable from the 404. So for security reasons, you were supposed to put up your own. All you do is you go to a folder, you look at the instructions, there's a place you just put a file called 404.htm, and that's your custom 404. You can define custom error pages. And this is recommended, this is what should happen at a company. If you put anything weird, you should still have the name of the company and like some links or something. But I didn't bother until there was actually security vulnerability in the one-in-one default 404 page.
Oh, what year was that?
Oh, maybe 10 years ago. But that happened pretty often. Netscape started all this. Netscape started putting ads in the error messages, and they started harvesting the mistyped URLs and sending it to someplace with ads. And this started the first huge argument about spam on the internet. Back in the days of like Netscape 2, suddenly if you mistyped a URL, you get a page full of ads, and everyone said, "You rotten bums, how could you do that?" And other people said, "Hey, that's brilliant, I want to do it too." And it started the modern internet, where both of those opinions have strong proponents. Anyway, all right. So here's other ways to do it. You can have parameter-based access control where there's some parameter in the request that determines what you're allowed to do. That's of course unwise because as we know, you can modify it with burp. You can look at the referrer to try to enforce that they came from the right page, and that's also pretty stupid because the referrer is under our control. And you can limit things by location. So you might have something here like admin equals true. So I tried this at some of those places to try and adding admin equals true to my request. It hasn't worked yet, but there are pages where this will work.
How about admin equals none? I don't know.
You can try that. There's one that said capture difficulty level, and I tried turning it to like easy and none and see if it would work. It didn't work, but I thought it might. Then the referrer, of course, shows the page you came from, except when it doesn't. And so if you believe that, you're a fool. And so obviously you can modify that to make it think you came from the other page. And you might have location restricted stuff like sports events that have a blackout in one town. And as everybody knows, all you do is find a proxy server in the right location and go through that. And now it thinks you're coming from there, just like I did by going down to PokeHub, so it thinks I'm in West Virginia. It's easy. I know if I go through my phone, I'm coming out in Atlanta, Georgia, so I mean, this is pretty easy to do.
You could try guest. Some routers still have a thing where you can log into a router as guest. You don't have privileges, but you can see what the settings are.
I suppose, but that's only local. I mean, the proxy usually has to actually be in the right country. But anyway, this is pretty easy to do, and other people that live in other nations get very practiced at this. There was a CTF from Iran, and one of the challenges was to fill up a map of the world by using proxies everywhere, because they're so many things are blocked there that everybody's a master at using proxies all over the place. In America, you don't usually have to because we don't block that much. All right, so Burp can compare the results of two user accounts. I used this a couple times. You just right-click and copy to comparer, and then right-click another one, copy to comparer, and then you can see the two things, and it will show you the difference. This is administrator, this is ordinary user. We've looked at this in the previous class, I think. It's a way to look for subtle differences. If you have two pages that are loaded in a slightly different way, so you might load something in the proxy from another state, and then without the proxy, and then compare it here to see how it looks different from another state. One of those retailers already observed that the behavior is quite different if you come from West Virginia than if you come from California. So there probably are interesting differences there. And here's the low privileged user who doesn't get a lot of these pages, like list users and such. Down here, they just get not authorized. So
That'd be related to, I know that some companies use like a service that localizes them and caches their stuff so it's faster somewhere. Maybe
almost everyone does.
Yeah, there's different security that they put in.
I haven't heard of any security in the reverse proxies. Okay. That's a common service. Content distribution services. Cloudflare does it. Akamai does it. Yeah, in principle, I guess you could pay to have it different in different locations. But as far as I've never heard of anyone doing that. Yeah. All I've heard anybody have is the same thing everywhere. But you certainly could.
Yeah. That'd be interesting.
In principle. All right.
That would make it very challenging to hack.
Yeah, it would.
You never know what you were going to get.
Well, you'd have to analyze each location separately. Anyway, so then you can try direct access to methods. So here's a post that goes up to the server, and you can see from the servlet here that it's using an IBM software. So you can spot what kind of servers are there. This tells you it's using an IBM HTTP server because it has those IBM type entries in the method. And so now you can walk through, log in as administrator and as a low privileged user, try to map it in both cases, and you might be able to find the pattern of URLs and parameters and guess what's missing. In very simple cases, many years ago, I've been to pages where I go to something that's login 2, and all I have to do is go to login 1. And I find the earlier version wasn't secure, and things like that. All right, so you can try other methods, post, get, head, and just add invalid methods and see if they're all really blocked, because some of them may be blocked with the wrong kind of filtering in the in the configuration files. So don't assume that users will not find hidden URLs or document identifiers or anything. Don't trust anything the user tells you. Don't assume that they came to the pages in the correct sequence or that they're not tampering with the data unless you have something like a signed ASP.NET view state where you actually have some control to make sure it has not been tampered with. You have no reason to assume it hasn't been tampered with. Yeah?
Sort of related. So for embargo countries and from the company here in the US,
Yeah.
in terms of setting up a framework, and you kind of know their IP ranges are, like what kind of a measure or
You want to know if people are bypassing your embargo?
yeah, or I mean,
Boy, that's a really tough one. The only defense I know where you control how many people are seeing pirate content, is you just learn where the proxy servers are. This is what, if you pay like a monthly subscription to one of these web app defense companies, they will supposedly keep an updated list of proxy servers. Like City College, you see blocked stuff like malware download sites. So if you try going through a proxy, it'll say proxy detected. That's why, something Kirk tried last year was setting up a proxy in the lab on the open internet to see who would use it. And when you put it on a common port, within a half an hour, somebody in China finds it and starts surfing porn through it. But if you just move it to an uncommon port, nobody ever finds it. So there's a bunch of bots searching the web constantly to find proxies, but they're only looking for the usual proxies in the usual places. But there's a huge need for them, primarily from China, because there's a huge number of users and their firewall blocks everything, so they're all trying to sneak past it. But other people use them too. And so the only thing I would say is you could know if people are accessing your forbidden content from a known proxy. But there's always new ones coming up. It's just like viruses or anything else. So that's how you limit it, though, by blocking known proxies and having some service that tells you as soon as new proxies come up. Other than that, the only thing I think you could do would be to look at your traffic and see if you're getting a lot of traffic from something that looks suspicious. then you might figure that's a proxy or somehow try to detect it. All right, so check your access control requirements. Make sure that everything really comes from the user session and not from something else. And you should just have one module or server or something somewhere that makes all access control decisions. So that there's not going to be an issue of different versions of software and stuff that can be fooled. Just like in Microsoft, you have an Active Directory domain controller, and every access control decision goes through that one component. So you never have some doubt about whether somebody's allowed to do something or not. There is one central point of control. So you might want to restrict access by IP address in addition to user accounts or with two-factor authentication. This is one form of two-factor authentication, an IP address plus a username and password for important things. And your static content should be passing the file name to a server-side program, which then decides if you're allowed to see it, or using some other authentication feature on the server so that if you aren't logged in as the right person, you really can't get to it. I don't trust resource identifiers from the client.
IP address, it's like, if someone goes to your website, like when you have the lab check-in, you'll see, on the screen someone's IP, if it's the lab or not.
Yeah.
So you could compare that IP address on VirusTotal. It'll tell you where the IP address supposedly is.
That's true. Yes. So if someone's coming,
you can run some script.
No, you're right.
On your website, pull the IP address of where they're coming from. Go to VirusTotal, put that IP address in, and have them look up what that IP is.
Yeah, and that's another form of finding the known proxies. You're quite correct. Anyway, two-factor authentication is good, and like to say, you should be logging things. I did find one of these retailers, it let me do like 10 or 20 requests, so I wrote a script to do 100, but I increased my script to do 1,000, and then I started getting error messages saying, we've reported you to the administration team, we're blocking you, and stuff. Well, that's what should happen, right? At some point, when you do this crap, you should start escalating it. So like I say, central access control is the way to do it. Everybody should just get used to using your central component. Now you can maintain it, you can update it. If you have to add more features to your website, you know how to add the authentication part by just connecting to the same old authentication system the same way. And that way you'll be much better off. So you'll have some kind of complex application, might have all these things: search, create things, edit things, purge things, and you have a list of the categories of people and what they're allowed to do, and your one central thing, like the domain controller, has this charge. And everything has to go through the domain controller to see whether you're allowed to do things. That's the right way to do it.
One big juicy target.
Yeah, well, that's of course, that's the way it is.
Yeah.
Now, and of course you have backup domain controllers in case it gets wiped out. But of course, that is the case. This is why some people don't like password managers, because now somebody can hack in there and get all my passwords. And I said, well, that's how it goes. You either put them someplace or you spray them all over the place, and they have different consequences. There's no perfect solution. All right. And so I have a couple examples of PHP vulnerabilities that are kind of fun. I'm not sure they're totally tied to this chapter, but it's sort of fun to see them. They got to be someplace. So here's a few I heard about, which turned out to be less of a severity than I thought. Whoa. Oh, that's going to put ping in it. Get rid of the ping. Okay, my server has been going down quite a bit because the 127 students keep hacking it, which is what they're supposed to do. All right, so this is something I heard of a lot, is weak typing. This is going to take a username and a password. In fact, I'm going to put this in Firefox so it quits filling things in automatically for me. I'm not sure we're going to need the proxy, but we might actually. So I'm just getting used to doing everything in Firefox of this hacking type. All right, so here we are. This uses that comparison. MD5 of the password you put in is compared to this MD5. That is the way a lot of people might write their PHP, and that turns out to be very unwise.
Oh.
So if I log in as root, I would have to find a password that hashes to that value, and I'm not going to be able to find it. It's not an obvious value. But you can feed in this number, 246, instead. And you can log in as root. Now the reason this works, this was all over the CTFs about 3 years ago, is because PHP is a weakly typing language. So if you put two equal signs, it guesses what the variable type is. It doesn't assume it's a string. What it does is, since this is 0e, a number, it assumes this is 0 times 10 to the 199 trillion, so it's 0. So any value that hashes to something of this structure, 0e followed by numbers, equals it, because it's also 0. And at first I thought, this is amazing. That would happen like one time in 256. I thought all you needed was the 0E, which means you could totally log in anywhere, like one account, but it's much, much rarer because you can't have any letters over here. So it's actually more like 1 in a million, a chance of this happening. So it's really not a significant risk, but it is kind of cute. And so the cure is you should have 3 equals, which I didn't know. 3 equals means it has to match exactly, even in variable type. So now it cannot misinterpret this as a number. It must treat it as a string. It must calculate the MD5, turn that to a string, and the strings have to match. Now you've accomplished what you want. You really have to put in whatever password MD5's to that to get in. Now here's another weak typing one. This is another cute one. This is also fail open. So if I have user and password and I log in, it won't let me in. But if I give it user and password now when I log in here, the password is up here in the URL. And let me see if I can, there. It's up here. So what you do is up there, you put brackets here.
Oh.
Now the password is interpreted as an array. And it's still letting me in, but I should be able to, let me go back. Let's try this. Yeah, okay, I don't know why I'm not succeeding on this one, but this is the one that should work. Let's see if I copy it, if it works. Yeah. Now what happens is I get in as root. And because I turned on error messages, you can see what happened. What happened is it expected the parameter to be a string, but it's an array. By putting a bracket around it, it's interpreted as an array. And so when you compare an array to a string, you get unexpected results. And that's what's happened here. If I can figure out, here it is, all right. So this is if the string comparison is 0, this is one way to make a fail open. If the string comparison fails, you get null. Null is equal to 0 because that's 2 equals. So this is one of those cases we talked about before where a failure causes you to get in instead of causing you to get thrown out. All right. And here's a PHP Handler. This one's kind of cute. One thing I always wondered is, how do I know script should run? If I go to a text file on a server, I just see it. If I go to HTML, I just see it. If I go to PHP, I only see the output. I don't see the source code. Well, it turns out that's in the web server configuration file. So here's something. So this one here is php5.txt. So if you go there, it just sits there. It doesn't run the PHP. So it's not just the presence of PHP here that makes it run. It's in fact the structure of the file name that makes it run. And it turns out that you configure it in your Apache configuration. And this is one way to do it. So you add a handler. So .php5 is the extension that makes things run. The problem is, if you write that string, which looks okay, it doesn't mean it has to end in .php5. It just means it has to have PHP5 somewhere. So I can go to this one, which is php5.txt, and it runs. Because this is another example of the same thing we talked about before about having different verbs not controlled. Apache configuration files are hard to write and confusing. This looks good, but it's wrong. There's another, the way you have to actually write it is this mess down here. Files match .+//.php5 dollars at the end. This makes sure the PHP5 has to be at the end, not in the middle. Otherwise, your developers put up files and don't think they're going to run, and they actually run. And if I have like a page where you can upload like your profile, and it can be a text file or an image, I can upload something full of PHP that ends in the extension to be text or ping, but it's actually running like PHP. This is why I say when you run a PHP server for a couple of years, you get hacked, in my experience, 80% of the time. Because when you first put it up, it might be okay, but after you put on a few more things and modify it, pretty soon you make some mistake like this, and there's a file upload vulnerability. People can hack, deface your web page. It happens all the bloody time. It's just too difficult to make mistakes like this with PHP. Too easy to make mistakes like this. So here's a request. So this will set a cookie, determining me a cookie is admin, now equals 0, all right? And I got some error messages, but I don't care. So now, so what I've done now I should be able to view my cookies. In fact, let's look at that in burp. That's probably the easiest thing to do here. So the last thing I did was this. And so the response here should have set a cookie up here. There, this set cookie.php. This is the request. This is the response. Yeah, there's what's going on down here. There it is. Set cookie is admin equals 0. Okay, and that should be here. Okay, so that's what I wanted to show you. So now I've set a cookie is admin equals 0, so I'm not the administrator. But what I can do is I can set the same parameter a second time elsewhere. So you go to this URL, and this one says you are the administrator. And the reason I'm the administrator is, well, you can see it right here. In the request is admin is 1. In the get request is admin is 1. Cookie of is admin is 0. This is what happens when you set things more than once.
Oh.
And you'll see it here. If I examine this request, the request itself has, in the URL is admin equals 1, but in the cookie is admin equals 0. This is legal. You can set the cookie multiple times, and different pieces of code on the server will give you different answers. So it depends on what language you're using, which one of these will matter. And so you can often override a parameter this way. That's why I was pretty surprised when I was messing with Amazon, and when you log in, they put your username in there twice, which is kind of screwy. And I tried deleting one of them, and it's just fine without them. But if they're different, different ones take priority. It's kind of weird, but you can totally define things twice, and these are the PHP commands which give you different answers. This tells you what's in the cookie, this tells you what's in the request. So your developer would probably use any of these interchangeably and assume they'll all tell you the truth, but they don't tell you exactly the same thing. Anyway, those are just a few examples of ones. Here's error reporting. By the way, having those big errors appear is considered unsightly and not professional for a professional server. What I did was I put display errors equal on, which is what you do for development, but you should not have it on a production server because you don't want users to see all that. And here's some links about it. Anyway, so I've got some of those Cahoots. Let's give them a shot. I think we're done with the slides. We are ready for the Cahoots. So this is chapter 8, and then I got to start the next chapter a little bit. Won't be too long, but we'll take a break before we do that. So if you access pages out of order, what are you doing? Okay, that's exploiting the logic. All right. If you read somebody else's email, what are you doing? Right, that's horizontal escalation. All right, which one of these is security through obscurity? An important concept? Yeah, that's unprotected functionality where you have something that is just hidden but not really protected.
Sam, these are like super fast, by the way.
Yeah.
No, they're only fast because everyone answered.
Oh.
Yeah, that's important. You get 20 seconds unless everybody answers, then it ends earlier.
Oh, okay.
Yeah.
The less people there is,
Yeah.
the less.
But then you can't change your mind.
You can never change your mind.
There's no changing
Because it's rating you by the speed of answering. So you have to get it right and fast to win.
Unless you're two people.
But it will never let you change your mind. That was the iClickers.
You have to have 2 accounts.
Unless you change your mind before all people have answered.
Well, I don't think you can even then. I don't think it'll change your score. I think all it looks is the first one to see if you're right, but I don't really know that.
Yeah.
It's a good point. I don't know if it'll let you change them, but it's rating you on speed, so I would think not, but that's a good question. I don't really know that.
No.
Anyway, all right, which one do you bypass with proxy servers? Okay, that's location-based. And the winners are Ray and Patrick and Ward. So I think we're ready to pick up here. So chapter 9 is attacking data stores. And I used to be a database administrator, so I'm pretty used to this stuff, but I thought it was best to break this into 2 lectures in case you haven't worked with databases. You have to get used to it. So SQL is the main type, structured query language. This is the original database. It's Originally, there were spreadsheets, 1, 2, 3 in Access, and people would put their stuff in spreadsheets, and then they would try to put their whole company in spreadsheets, so they have their employees and their paychecks and their taxes and their orders and their customers, and pretty soon you get a mess. You need a little bit more complicated data structure than that, and the sweet spot for almost everybody is a relational database, which is what SQL does. Now, a few people have tried to move beyond SQL to NoSQL, and it's pretty much turned into a boondoggle. I know Facebook moved to it and then moved back, but the original SQL relational databases are intended to have a complete, exact copy of all the data in one place. And anyway, so SQL is the most common type. There are ones that use XML and LDAP also. And this is, of course, a high-value target like the domain controller. Your database has all the goodies. Usernames, passwords, they might be hashed, credit card numbers, orders, tax information, social security numbers, everything you got is in the database. And so, and then like I say, number one vulnerability in web apps forever, all the way back to the beginning of the OAuth top 10 has always been SQL injection. It is the most dangerous, most deadly thing to happen, easiest to exploit, and more than 90% of all the stolen data was stolen this way, although that statistic is from like 3 years ago, and it seems to me like open Amazon S3 buckets must be giving it a run for its money now. That seems to be the latest way to lose 100 million records without trying. Anyway, so this is the fundamental weakness here is injection. And the problem is if you have an interpreted language where a human is expected to be typing in lines of code, they are then interpreted by the computer, so it tries to guess what you're trying to say. And this involves matching open parentheses with closed parentheses, open quotes with end quotes, and that is really risky. So in principle, you should not be using interpreted languages in your programmed code. You should be using compiled languages. It would be a lot safer, but people don't. So they write apps that actually generate code and then hand it to an interpreter on the fly, which is the fundamental reason for all code injection vulnerabilities. And so this can be as simple as this one, which we've used in my other classes, although I think not this one. Maybe you did. I don't know if you did this one in this class or not, but let me just start with this one and we'll go on to the others. There's the ping vulnerability. Let's go to attack 2.
I think that was our first assignment.
You did it, good. So you've done this one, yeah. That's what I thought. So let me just bring it up so you know what we're talking about. All right, so this is the simplest one, where it's supposed to take google.com and ping it. But unfortunately, instead of the developer writing this whole page in some language like C or PHP, they used PHP to write a line of bash and then send it to bash with the OS system command. Right. And that means that's the mistake. The mistake is when you use one language to write code which you hand over to another language. So that's why if I do something, if I write bash in this PHP field with a semicolon ls, that's a bash system of putting two commands on one line. It will pass that out of PHP into bash and execute the ls. And this is the fundamental error of code injection. So it's what you get from being too lazy to actually learn how to do what you want in one language and instead just passing it on to another language with automatically generated code using user input. So it's much harder to do with compiled languages. That's essentially what buffer overflows are doing. We're doing that in 127. But if you're going to inject into a compiled language, you have to inject assembly code. And we're doing that, but that is a lot more difficult than injecting high-level languages like bash or SQL. So if you want to bypass a login, your SQL will look something like this. Select some stuff from the users table where username equals Marcus and password equals secret, and the Marcus and secret are data that came from the user. And it has to match these apostrophes and those apostrophes in order to interpret that command. So if I put in an input that has an apostrophe in it, like admin apostrophe, it will turn into this, select users where username equals admin, and if I put a dash dash here, it'll be a comment line, and the rest of it will never be processed. Without the dash dash, it will be a mismatched apostrophe and give me a syntax error. But with the dash dash, it works. So this slide should have a dash dash there. Oops, I'd feel better if it did. There. Anyway, all right. So that's the most common SQL injection, apostrophe or 1 equals 1 dash dash. we'll make username equals nothing or 1 equals 1 and ignore the rest. This is a compound condition where this or that, this is not true, but that is true. So we'll now proceed to whatever was going to happen if this condition was true, which usually authenticates you as the first user in the database, which is usually root. So that's the game. So we've done this already. You did this in an earlier project. So that is SQL. Now you can use union to combine two queries. So let me go do some of this stuff live in this table. Just so you know you have played with it in the projects, but I want to just do it as kind of a review to make sure you've got it. So if I go to the SQL here, let's reset it, because people can certainly be defacing it and such. All right, so if I select everything from SQL users, I'll get this, the name and isadmin. So that's everything. Okay, now I can do a union, and I should have, there we are, here's one. This will add two fields together. Now here we can play a few games here. When I select everything from SQL users, I get two fields. The first field is a text field, and the second field is a numbered field. Now, if I do this, I select username from SQL users. Let's just start with that. If I select just the username, then I get only one column of just usernames, which is what I expect. Okay, now, if I do this, it's going to take the username from the users and the SSN from the SSN, and it's going to call that a username and add it to the username field. You can combine two queries with union, and what it'll do is run the first one and give you the results, and run the second one and add the results to the table. So there's 5 entries, but I get 10 columns of data, 10 rows of data here. First I get the first 5, then I get the next 5. Now, if the first column here was numbers, this wouldn't have worked, so let's try that. If I select the other field, which is isadmin here, and then do this, now it did work, which is strange. I got 1s and 0s. I thought I'd interpret this as a number, but instead it interpreted it as text. Normally I'd expect to see an error there. Anyway, let's play another game here. Let's select star. And now it doesn't work. Now notice the error. The select statements have different numbers of columns. You can't take something with 2 columns and add a table with 1 column to it. It won't let you do it. So that's why you have to do something to make the numbers balanced. So what I could do is I could get rid of this, and I could select SSN twice. Now there's 2 columns. I still didn't like it. I thought I'd settle for that. Let's try null. See what that does. Still doesn't do it. All right, let's try null. I'm not going to go on to my quiz if this doesn't just carry on as usual. Nope, okay. We'll come back to this. I thought I had that set to go, but anyway. All right, so there's union that adds 2 things together. At the end, you often have to have a comment to avoid breaking the syntax, and there are many different kinds of comments. This is for Microsoft databases. These other comment characters are available. When I'm doing capture the flags, you just have to try them all. Very often the comment that you expect doesn't work. So in union, you have to have the same structure, the same number of fields, and the same data types. So here's the one with the wrong number of columns. Let me try setting this one up. Herp derper union select name SSN.
So if
The
you
one I
figure
tried
out
before didn't work.
which kind of comment it is, you can kind of discern what kind of database it's running underneath?
You can, but there are much better ways.
Okay.
There are ways to fingerprint a database. So let's try herp derper, and I want to get, okay, it's herp derper union select name SSN. Okay, union. Let's just do this one. Now here, by the way, this is the realistic form where all I control is the name. I'm not getting the whole select query. So here, I'm getting no usernames found, which is actually kind of strange. There should have been one. Oh, there's a space. Ah, okay. If I get rid of the space, now I find the one username herp derper. Now I'm all right. Okay, now I try union. Now if I do this, it's not going to work because it's interpreting that all as the name. Username like herp derper union select null. I have to be more careful. And it's going to have to be like this, union select. Now I can put an apostrophe here, and now I can select null, but I'm going to have to somehow have an extra apostrophe later. So one thing I can do is put in a comment. So if I do that, now it works. I got herp derper and a null. This is what I wanted to show you. Now if I select everything, not the username, oh, I can't change that. All right. Now if I were to do 2 here, there. Now they don't match. This is why if you don't know the data type, you just select nulls until it works, and now you know how many columns there are. Now if you don't know if it's a number or text, you can just put numbers here. And it didn't like it because I had 2 columns. Let me get rid of the null. Okay. Now it'll put a 1 there. Now text will let me have anything. If this was a number, I couldn't put text below it. All right, anyway, that's so let's go back to the slides. Those are some demonstrations. So this is, you can have letters and then numbers under them, and that will work. All right, so here's how you find the number of columns. Apostrophe union, select null, 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 null. And what's funny, I found some, I just queried for a while. See, there was a tweet like 5 years ago from a security researcher that said, just try Googling for select from in the URL. There are hundreds of websites that have SQL up in the URL. They've written a database. You can shop for things, and when you shop for it, it just picks them out with SQL. Right there. This is not even command injection now. It's just right there in front of you. This is like I have a shop that just gives you a command prompt. It says, okay, type commands and take be sure and put your money in that cardboard box there before you leave. You know, I said, you know, I thought about telling these people. I said, you know, I really don't know how I could even communicate with someone that would make a website like that. But anyway, there are hundreds of them out there. That's why people say you just want to give up and cry and hide in the corner when you see people doing this. It's just appalling. But anyway, because of that, I found a bunch of websites that were automatically generated from automatic SQL injection tools. And a lot of them have this. Select null, null, null. This is a common thing. Select 1, 2, 3, 1, 2, 3, 4. The automated tools do these queries. They have a series of steps. And so first you do this to find out how many columns there are, because null matches any type. Now you know how many columns there are. Then it will do things like 1, 2, 3, 1, 2, 3, 4, and so on to get in. So here's union select null. It'll give me herp, derper, and then a null. So if you want to find out if a column is a string, you now select a null, 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 a null, 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 a, and you'll get an error message if the fields are numeric. And you'll find out which fields are strings because they won't give you an error message. By the way, even most databases will not print out a table. They're just using it to make a decision. They're not printing out the result. So you do see an error or no error. And if you don't even see an error message, then they call that blind SQL injection. And there are a lot of tricks to do that, where you have to look for something more subtle than something visible on the page. Some character that's different, or maybe the time it takes to load will be different. You have to find some difference between a true and a false statement. And someone was asking about how to identify your databases. This is one clue. You can use @version, and that will tell you on MySQL what version you have. I wonder what happens. I think mine should work. If I select @version, let's try that on mine. Mine is, of course, MySQL because I didn't pay any money for it. So here I have herp derper union select 1, and that gives me a 1, so I could do union select @version. And there we go, 5.716 Ubuntu. That's the version of MySQL I'm using. So that's one way to find out what you got. And, all right, there it is. All right, and this one's kind of funny. When I did Google searches for these queries, I found one of these. This is a Montserrat College of Art. They're in San Francisco. I notified them about this years ago. This is the administrator password and username just sitting there. And I didn't find it by injection. This is the URL that was posted on some Russian forum. This is the URL, ID equals -1, union select 201, group concat, username, password 4, 5, 6, 7, 8, 9, 10. This is an automatic injection tool using exactly these techniques, probably exactly from this textbook, to hack in and then posting it on the forum. So I found it this way. I didn't hack these guys. Somebody else hacked them, and I found this page. And I told them for years they wouldn't listen to me, they wouldn't talk to me, they wouldn't let me come fix it for them. They wouldn't do anything. But one thing, by the way, I should mention is I could never crack that hash. So it really didn't leak anything valuable as far as I could tell. I don't know what, that's like SHA-1 hash or something, I could never crack it. I think it might actually be an MD5 hash, but I couldn't find the plain text. I tried before I found out there's laws against that too. Everything fun. There's laws against everything fun. Anyway, so they eventually did replace the server or something, but I spent years trying to get their attention with no luck. All right. That's why, all right, we'll talk about this later. So SQL, here's some examples. If you search for name equals Matthew, you'll see this, Matthew Adamson, and an email. All right, that's searching the address book. So you first need to find the required number of columns. So you search for Matthew union select null. Now see, the fact that I had one Matthew appear on the screen does not mean that the select query only pulled out one field. It just means the developer only chose to print one for me to see it. So you have to try null, null, comma, null, null, comma, null to find out how many fields are actually used in the query. So here an error occurs until you have 5 fields. So even though I only see 2 fields on the screen, the actual query has 5 fields. That's the one that actually works. All right, so now you verify that the first field has a string in it by adding an A, and it goes in here. So this is indeed the first field, and it's a string. Now you can get table and column names. This is the way you do it is you go for an automatically generated table that has these. It's in the database. Information schema columns, that contains the information about what the names of columns and tables are. So now you get that information here. Those are table and column names appearing. Now you can get credentials, because now that you've found, if you look at your names and column names, here's username and password in a table called users. You need to know those in order to ask for them. And now you can select username, password from users, and you have to have some nulls to fill it out to the right number of columns. And now you get the usernames and passwords. And this is how you do it. And of course, if you use an automated tool like Havij or SQL Map, it can be very easy. So that's all I wanted to show you. That's using the right amount of time today. And let's do the cahoots that go with this, which is here. Okay, which SQL method will combine 2 queries together? Okay, union. All right. What's the purpose of that injection? Null null tells you how many columns you have. What's the free open source database? MySQL, good. Actually, now it's called Maria.
Oh.
They
Whatever we got there.
changed it in Ubuntu. Anyway, all right, if this injection succeeds, what have you learned? Okay, the second column is text. Okay, so it's Ward F, and oh hell, I'm going to have to find out who they are.
Me.
Okay, good, all right. And Matt. Matt's a real name. All right,